Hey guys, so today you and I are going to talk about architecture. So let's get into it. So the question in question was, hi Frederick, how do you transform a software architecture? Oh, this is a good one. So my first question is, are you talking about at a single project level or at a company level or like a systems level? It depends on how you want to see it, like, because you can say system levels, company level. I mean, let's not dive too much into the details, but basically my question is it at the code, like a single repository level, like just the system like that you're working on, or is it like the entire architecture of like some larger system with multiple services, or at like a gigantic corporation level type of thing? There are many layers to this. I'll give you a brief one for each of them, because they sort of in themselves require a lot of talking and could probably make up several videos, but let's just dive in. So if we're going to talk about the code level, it's usually very simple. The way to transform the architecture is sort of understanding first and foremost, why are you doing the transformation, what is the ideal state, and what is the net benefit of you getting there. Basically, where is your definition of done? This is number one. The reason why you want a definition of done is because you need to know what changes to make in order to get there, so that you can segment the journey there into pieces. Those pieces become stories in some type of epic. In other words, there is a end goal when you are done. Do you know how often I see that happening when people talk about migration? Practically never. It's basically, people migrate from tool A to tool B or use framework C, and that is their definition of done, because it's not about some end state, it's about using a new tool. That's their end state. And so when I talk about an end state, I usually talk about, all right, I need to either comply with some legal requirement, some product requirement, or some way of working so that I can fulfill this bigger goal. To give you a very concrete example, I've done this journey a few times now. So in one of the companies that I worked at, they had what they call the golden path. In other words, the golden path, or a golden path, is basically just, you can think of it as a tech radar type of thing. You have a set of main frameworks or tools, or like a tech stack that you want more teams to be leveraging, because you want more synergy between code bases, more familiarity, and less entropy and inconsistency between the different projects. So this works at two levels. They want a specific tech stack to be there, but they also want a consistent quality level of the system that they're dealing with. Now, how do I go about doing that? Well, the first part is fairly simple. You know that you need to use, say, in this case, this was for these specific project, it was a full stack Node.js setup. So they want to use Next.js, React, Jest, and TypeScript for all of their projects, basically. And so the first thing is very simple. You do a code inventory. You basically go through, in this case it's a single project, so you go through the code and you see, okay, these are the dependencies we have, these are the architectures that we're dealing with. How much from my list is already there, and what is there that is not consistent with what we're trying to achieve, like what frameworks are they using and all of this good stuff, right? And then you start looking at, all right, so if for example, now we were using at one project Nest.js instead of Next, and a completely different architecture, a backend for front-end type of setup with two different, like a static application, search or create React app, and a backend system using Nest, basically two applications working together. And so the inventory is very simple here, because you basically just have to go through, all right, if I wanted to convert this system into that system, how would I be able to do that in the cheapest, simplest way possible, which does not require you to stop all development and just rewrite everything? Because you can't when you do when you transform an architecture. Basically, almost always, any solution that means stop all development and just do a full rewrite over several months is a no-go in basically any software architecture transformation. You need to think about it in iterations. How do you take steps towards the end goal? So that's what you do. That's what the code inventory is there to do. You basically just have to go through how and break it down to manageable pieces. And so what I usually say is start picking leaves. And so in the nest versus next situation, you have all these, the front-end application part of the system is being already handled by, say, in this case, it was Create React App. So your first goal should be fairly simple. How would you convert that to Next? Well, very simple. You migrate from Create React App to Next and you serve up the same front-end. Cool. That's step number 1. Step number 2 would be, all right, so now you need to remove that backend from front-end thing because they want to run everything for Next. So how do you do that? Well, you pick your leaves. Well, which dependency could you move without having to rewrite everything? Well, since right now these two things are communicating, the first thing you would do is to stub off the one of the backend calls from the front-end application that goes to the backend and handle that from the next application. So your first priority should be to take a look at the different routes within the backend system and say, all right, let's take one route and move that to the front-end application and prove that you can serve that specific request from your new application and still handle the other ones from the backend, for example. And then you can iterate through it and just move endpoint by endpoint, for example. And then you can these are framework specific tips and things like that, but you can decouple code and so forth, where you break out the business logic into, vanilla JavaScript type of setups. Because say Nest, for example, has a lot of these weird annotations and stuff like that is framework specific. That is not much of an issue. Then you break it down and say, all right, let's convert all the logic that we need to move to Next. You can't just rewrite it, but you can convert that to a state where it's basically just ES6, and then you can start moving things fairly simply. And for a larger system at the company level, it's basically the same structure, but it is at a more macro level where picking these is still the way to do it. Basically, you have to ask the fundamental question: what state do you want to achieve? And then you have to figure out, and you have to have knowledge, of course, how to actually be in that state. And the biggest mistake you can do here is, as I said, to do it all at the same time. That's never going to work. So in a larger organization or in a larger project, your first thing is to do it for one leaf. In other words, your leaves in the code is basically just dependencies like logic, abstractions, functions, things like that. In the system level, it's services. So you need to take a look at each of the different product teams or whatever you're dealing with and take a look at, okay, which of these systems can I convert into the state that I want to have for the entire company, basically, and make a proof of concept of moving them to the ideal situation. Take those learnings that you will get from having that journey with them, and when they are in that state, you take on the next one. And then the next one, and you're looking for systems that have fertile ground for making these sorts of transitions, because this will mature your understanding of, because there's no way you're going to understand a really large system. There's no way, this is the biggest mistake some people do. They try to understand the whole system as one gigantic thing. It's it's never going to work, ever. And so my argument is that if you can take it piece by piece, because if this idea that we have, it's basically unit testing, or the idea of unit testing is that if you test each individual component or each individual part of a greater whole, you can be certain that the greater whole has is covered. But that's not, and you can apply the same mentality here. You simply have to know that if you make one service work really, really well, and in accordance with how you want it to work, then that thing is going to fit with the next thing, and then the next thing. Because if you have an architecture that actually doesn't work, you will find that you just run into new problems every time you try to change something, and then your architecture is probably not suited for whatever you're trying to do. But if you're doing it correctly, you should find that each leaf or each thing that you're trying to move over to the state that you want actually just it becomes easier and easier. as you go along, because the more times you move one of the leaf nodes within like your system or in your code, the easier it becomes to move other stuff. And you will just find that it's actually very natural, because almost every system, especially even at the code level, it's just a set of dependencies. And when you start to understand how those dependencies work together, it's usually very easy to just pick one of those things that is fairly easy to move into a new state without having it break a bunch of other stuff. You don't want something that is very central to absolutely everything. You want to start with something that is loosely coupled, so you can try out your ideas and then learn from that and pick the next leap. And then after you do this enough times, you will have very solid, because every time you do it, it becomes easier, and you will build up a solid strategy for how to do it for larger and larger systems. And before you know it, you actually moved most of, if not all, I've never been in a company for long enough to do that for a really large system, but you will get to the an almost streamlined process for migrating systems in this fashion, because you're approaching it, as I said, as picking each individual thing that you can do, and like the smallest thing that you can do, breaking that into smaller like tasks or work tasks, divide and conquer basically, moving each piece, and then when you're in your done state, move on to the next thing. And you should be able to repeat that process like over and over and over. That's how you know that you actually have a solution that is going to work. So what I want you to take away from this is that transforming a software architecture at the code level is very similar to at the system level. It basically comes down to you understanding the system and the end state that you want to be in. So as I said, an example would be, in my case, you want to have a specific tech stack. Then you have to figure out how would you get that tech stack in steps, because you can't just sit down and rewrite everything in one big bang, because you have to be able to continuously working on things while doing the migration. So you have to have this in-between state that actually is stable enough that you can move piece by piece whenever the capacity is in your favor. And that is usually easily done by figuring out where are your dependencies, what things can you move around or change without a lot of cost to the end system, and break it down into digestible tasks, or like basically stories. And then you create a roadmap, and then you just pick the story that will take you one step further to unblocking the next thing you want to do, and then the next thing gets unblocked, and then the next thing gets unblocked. It's basically a topology where you can't just pick an arbitrary task and start refactoring shit or like moving things. You have to pick the thing that would be very easy to transfer so that it unblocks the next thing and the next thing. That's basically what it comes down to. It's the same thing at the system level. If you have a grand architect type of thing going on in your head, it's very unlikely that you're going to make that work as like over an entire system. It's better for you to understand a way of working, or getting to, as I said, defining your end state. How should each of these systems work as an individual node? Get one node or one product team or one product to that state so that they are working and doing things in your dream way, so you can make a small proof of concept idea of it and see how well that works. Learn from it and then do it for the next system and then the next system, because it spreads. Instead of doing it over everybody at the same time, you go team by team until it becomes an infection type of thing, right? You get more and more momentum the more times you do it. This way works, I would say, pretty gosh darn well. And usually it's actually it's not as hard as you think. The tricky part is finding the people who know how to achieve that end state in an efficient way without causing a lot of these issues as I'm talking about. And most importantly of all, who defines what that ideal end state is? Are they the right person? Because there's a lot of people who have a lot of big ideas on what a perfect software architecture looks like, but there's not that many people who get it right. Have a great day.